Okay, hi guys. So, sorry that I only uploaded half of the video. Not sure quite what happened there, but either way, here are the next 6 questions. So, question 7. Question 7. 3 equals 1 minus 2n. Okay, let's go over here. 3, 1, 2, 3. 3 equals 1 negative 2n. So remember, when the 2 is right beside n, it means 2 times n, essentially. So it wouldn't be 2 negatives like this, okay? It would be these two variables. Okay, so what are we gonna do here? Let's see. I want to get this out of here. So do my negative pairs. Awesome. And then I'm left with this, and we haven't done this with a negative, but you can do the same thing that we were doing with the positives earlier when we were dividing. So I'm just gonna flip these like this so that it's obvious. So one of these is equal to 1. So n, negative n, equals 1. Okay. And let's solve this symbolically so we make sure that we know what we're doing. And again, I'm just going to flip it because I find it easier. You don't have to do this. I'm going to get rid of my 1. So this is a positive 1. Don't forget, this is secretly a positive. So I'm going to subtract 1. And then I have my negative 2n. So these are going to cancel each other out. Equals 3 minus 1. So I'm left with negative 2n equals 2. And then I want to get rid of this 2. Ooh, I don't really care about the negative for right now. So divided by 2, divide that by 2. So I'm left with negative n equals 1, which is exactly what we found earlier. Okay, let's do question 8. Question 8. This one's going to be interesting. R over 2 minus 1 equals 5. Okay, so we're going to have to think about how we're going to show this one. So let's see. We have, first I'm going to put the things that I definitely know. I know negative 1 and I know 5. So now how am I supposed to represent this r over 2? Well, really r over 2, that's just another way of showing r divided by 2, right? So I'm going to put r, which I know is positive, and I'm going to split it into 2 because that's basically what I'm doing. I have half of these. So I'm going to use my negative pairs to move this over here. Get out of here. And here's where 1, 2, 3, 4, 5, 6. So this, splitting these, this is the opposite of multiplying. We're dividing. So we're looking at what one of these is equal to. And one of these is equal to 1, 2, 3, 4, 5, 6. To 6. And because we've divided this, right, to get rid of this r, this half r, we're going to have to multiply, which you'll see when we do this symbolically. So our answer is actually, because we do still have 2 of these, we don't have just 1, we have 2. So our answer is actually 2 of these. So it's not 6, it's not half r equals 6, it's whole r equals 12 of these, right? And unfortunately, there's not enough of these to show you 12, but 2 of these, 1 of these is equal to 6, but I have 2, so it's going to be equal to 12, even though I can't show it to you. So let's do this symbolically so you can see what I'm talking about. So r over 2, and just like we did with our tiles, we're going to get rid of that 1. So that leaves me with r over 2 equals 6. And now here's where I was saying, so to get rid of this 2, we're going to have to multiply, right? So r over 2 times 2 equals 6 times 2. That's how we get rid of this, right? So now that we have our single r, it's worth 12. Okay, let's go on to number 9. 3x minus x equals 4. So let's see. I have 3x minus x, and a negative x equals 1, 2, 3, 4. Okay, so right away, this is easy because this creates a 0 pair. So I can just get rid of 2 of those. And then from here, hopefully that seems really obvious that all we need to do is divide. So x, a single x, is equal to 2. Or I guess in this case, yeah, it is x. Okay, good. Confused myself for a sec. So let's show it here. So 3x minus x, well, we can think of this as 3x minus 1x, right? The 1 is just invisible. So 3 minus 1 is 2, right? And we don't really have to do that on the other side because we haven't added anything, right? So then we divide. So my single x equals 2. Awesome. Okay. Getting close to the end here. Do question 10. Okay. 3t minus 1 equals t plus 3. Okay. So this one is kind of interesting because it has variables on both sides of the equal sign. So let's set this up for ourselves here. 3t, 1, 2, 3t minus 1 equals t plus 3. Okay, so I want all my t's on the same side. But first I'm gonna get rid of I'm gonna move all my like regular numbers, my integers, over to one side. So I think I'm just gonna go like this. Cool. So I got my couple of negative pairs. Oh, whoops. Hold on. Oh, I totally did that wrong. Ha 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 ha. Silly me. Should have been like this. There we go. That's better. Okay, and now I want my variables on the same side, and I think I'm going to put them on the left side. So just like that. That makes a negative pair. Okay, and now I just need to divide. So this one is pretty simple, no problem. T equals 2. A single t equals 2. Let's see if we can get the same result doing it symbolically. So 3t minus 1 plus 1 equals t plus 3 plus 1. So those two equal each other out. Plus 4. So I'm going to go 3t equals t minus, oh, actually, I better leave some room here. 3t equals t minus t, and then I did it on the right, so I have to do it on the left. Plus 4, so those t's cross each other out. And then 3t minus t leaves you with 2t equals 4. And then I can divide to get rid of my 2's. So t equals 4. Nope. Oh my goodness, not 4, sorry. 2. 2. T equals 2. There we go. Okay, second last question. Question number 11. 4 equals 1 minus 2m. Okay. 4, 1, 2, 3, 4 equals 1 and negative 2m. Cool. Okay, let's get our integer out of the way. Get out of here, you. Okay, so now I'm going to divide here. Aha, so we've run into a problem, and all we have to do is split our little block, right? So, and again, I don't mind if you leave the variable negative. So negative m equals 1 and a half. Let's make sure we can do it symbolically. And I'm just going to flip it around because I find it easier. 1 minus 1, because remember this is a little plus there, equals 2m equals 4 minus 1. So that equals this up. Negative 2m equals 3. Divide by 2. Negative m equals 1.5, because 3 divided by 2 is 1.5. Okay, very last question. 12. C plus 1 equals 2c minus 1. Okay. So here's another one that's got these variables on both sides. So c plus 1 equals 2c minus 1. Okay. Which side do I want to move my variable to? I think I'm gonna move it to this side. So it gets that out of there, and I want to move my variable over here. Sweet, that was an easy one. Yeah, no problem. C equals 2. Let's do it symbolically. So c plus 1 minus 1 equals 2. Oh, actually. Hold up. Hold up. Oh, I see. Ha 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 ha. I don't want a double negative, so I'm just going to do it the other way. And then I get to add one over here instead. So c plus 2 equals 2c. And then I want to get rid of this c that is awkwardly here, so I'm going to subtract it. Minus 2c minus c. Yep. So 2 equals, and 2c minus c is just c, 1c. Awesome. So hopefully, guys, kind of what you took out of this is that there's lots of different ways that you can solve these. You can decide to solve them left to right, right to left. You can change your mind about, for example, this one. I decided I didn't want to have a double negative on this side because it was easier to just work with sort of regular integers. It is entirely up to you. And hopefully you also found the algebra tiles at least interesting, even if you don't think that you'll probably use them. As always, if you have any other questions, just reach out to me.